Okay, video number 4. This particular video is where we really start to put some pieces together so that we can start to do some converting. So this is where I would start by saying we are going to discuss how to do unit conversions starting now. And we're going to take a few videos to kind of lay out different, some basic rules, but then how, depending on what the units that you're looking at look like, how you have to structure your unit conversion work so you can get the right answer. Because I want to emphasize again, the one thing that I do not accept is when people just tell me, oh, well, I converted it in my head and I just did it on the calculator. I want to see a structure, a step-by-step breakdown on paper about how you went from one unit to another. Now, I'm going to start by talking about a real simple example of this. Let's say, and that is going back and forth between inches and feet. Because this is one that most people would do just intuitively, but I want to point something out. If I were to tell you I have 36 inches and I need to convert that over to feet, most people would easily be able to just tell me, well, it's 3 feet. And if I asked you, well, how did you get from the 36 to the 3? You would say, well, I divided by the number 12. And if I ask you, well, why did you divide by the number 12, or why did you do that? You would give me this justification, most likely. Because there are 12 inches in 1 foot. And most people would go, that makes perfect sense, because they grow up with this. And if this is where it all ended, I'm not sure I'd have much to say about it, but let's look at a different example. Let's say this time I tell you I have 5 feet and I need to get that over to inches. Now again, most people would be able to quickly say, well, that's 60. And if I ask you, well, how did you get there? You say, well, I multiplied by 12. And then when I ask, well, why did you multiply by 12? Most people will come back with, again, because there's 12 inches in 1 foot. And here's where I want to point out the problem. When it comes to your justification for what you did, you are giving me the same justification in both scenarios. You're saying, I did this because there's 12 inches in 1 foot. But the problem is, in one case you divided by the 12, and in another case you multiplied by the 12. So simply saying, well, I did that because there's 12 inches in 1 foot, that is not a clear justification for why you multiply or divide by 12, depending on what you're doing. And that is kind of a simple example of why I say I do not accept it, at least at this level, when people just tell me, I just did this math and here's my answer. After you've done enough of it, you do kind of, you can reason your way through, or you've done it so often you just know what to do. But I want to break this down into the mathematical reasoning why you use the same justification, but in one case you multiply by a given number, and in another you divide by that number. Now, the heart of all conversions comes down to the concept of ratios in math. So let's go back to 36 inches, and I want to figure out how many feet are in it. Now, in order to do this, at least in one step, you have to know the relationship between these two different units. Now, I chose this because it's, a simple one that most people say, I know the relationship. So you would have to be able to say, I know there's 12 inches in 1 foot. And so now, in order to solve this, what you would do is you would set up a ratio, and you would take what you want here, or what you've been given, and to make it easy, we're going to say, well, the thing that I want to know, I am going to give it a letter X, and I'm going to put that on top, and the equivalent in inches that I've been given is 36. Now, in order for us to set up a proper ratio here, the only way that works is if I have the same units on the same side of the fraction on the other side of the equal sign. And as much as people don't like geometry, when you have similar triangles, you play games like this because ratios, proportions are similar. So the idea is if you had one side in the numerator from one triangle, you have to have the corresponding side in the similar triangle in the numerator as well, or else things wouldn't work out properly. So when it comes to conversions, that means you have to set up your ratio so that you have the same units in the numerator and denominator. But on one side is the thing that you're trying to solve, and on the other side is the conversion factor that relates those units to each other. And so on this side, we would have a 1 here, and we would have a 12 here. Now, in order to solve this, we need to isolate the x, so we would end up multiplying both sides by 36, and we would end up with x feet equals this math. Now, I am going to reverse this, and I am going to write this as a fraction here. And so now, in order to solve for this, when you look at what you've put together here, you have 36 multiplied by 1 over 12. And when you multiply by 1 over 12, that is mathematically the same thing as dividing. Because if you bring it all together, you would have 36 inches times 1 foot over 12 inches. And so you would end up with 36 divided by 12. And in addition to this, if you look at the units, and this is one of the key pieces that I'm going to come back to later when we put together what I'm going to refer to as the shortcut rule, you'll notice that the inches cancel. This is the reason that we know this is going to work, because since the inches cancel, the only unit left is foot. So when you do this math, you end up with 3 feet. Now if we come over here and we do the other example, 5 feet equals x inches. Now again, we have to know the relationship between feet and inches. It's the same relationship that we used here. 12 inches equals 1 foot. And we go ahead and we set up another ratio again. And again, because to make the math easier or simpler, we're going to put what we want on top. So we would have x inches up here, and we would have 5 feet here. And on the other side, we would have to have the inches and feet on the same side of the fraction as what we started with here. Now notice they are flipped in this example. The truth is, it wouldn't matter whether we started this x inches on top and the 5 on the bottom, or flipped. We would have to adjust on the other side, but in the end, the math would work out exactly the same. So we put our 12 inches and 1 foot here, and when we say, okay, I want to isolate the x, I multiply both sides by 5 feet, because the 5 feet end up canceling, and I'm left with x inches on this side. And again, I'm going to flip these two factors around, and I would have 5 feet times 12 inches over 1 foot. So now if you look at the math that we need to do to solve our conversion here, if we bring it all together like we did over here, we have 5 feet times 12 inches over 1 foot, and then we have inches on this side. And because of the math that's set up, this time we have a 12 in here, just like we had over here, but this time the 12 is being multiplied by the 5, and that gives us our answer of 60 here. And if you look within the math, the units of feet cancel, and that's what allows the inches, I guess you could say, to survive. So when you're doing conversions, there are two levels that you have to kind of process, and I don't want to say that they're simultaneous, like at the same moment. They're kind of like parallel things going on. But the thing that drives your setup are the units, because if you don't have the matching units on both sides here, what will happen is you will not get the cancellation that you need to have happen here, which tells you that you're getting the right final unit on the answer. And once you have the units set up properly, you just do the math or process the numbers the way the math tells you to. So on the left here, we divided by 12. But the reason we divided by 12 was because the setup ended up dictating that we divided by the 12. Whereas over here, our setup, following our proper rules here, when we isolated the thing we were looking for, we still used the 12, but this time the 12 was on the other side of the fraction, and that meant we were multiplying by 12. So I hope you're seeing here that there is I'm going to say a level of sophistication. When someone says, just multiply or divide by this value to get this new unit that you want, there's a lot of this that has been done in the background so that people understand that the number, once you multiply or divide by that value, is going to be correct. And the correctness of that is based upon how the units set up, not the numbers. So I will constantly come back to that because this thing about doing unit conversions, this is one of my harsh statements. If you can't figure this out, there's part of me that wonders whether you should really be going into science, because this type of concept is a base background mathematical principle that if you say, I like science and I want to go further on in science, especially a physical science where math is an important thing, this thing about units and using units to guide your calculations is a critical one. And when you go to higher levels, if you don't understand that this is a big deal, you will make, you potentially will make silly mistakes that at higher levels, I'm not sure if they interpret them as silly, they interpret them as not too smart. Okay, so this is your very, very rudimentary introduction to about as simple a unit conversion as possible. And now what we're going to do is we're going to look at a second one that's just a little more complicated. All right? And I got my timer going. So here, what we're going to look at, change colors to keep it interesting. Let's say somebody tells you they've measured 47,100 inches, and they need to know how many miles is that. Now, at this point, you could say, well, I could do this just like I did the last one if I only knew how many inches were in a mile. And, you know, in today's world, people say, well, you can go Google that. Sure. But at the same time, if you could come up with that number, which I don't know it off the top of my head, because you don't have to, really, I don't know whether that would make people go, damn, they must be smart, or if they would end up saying, this guy, this person's kind of weird. Because people usually just don't know that kind of stuff off the top of their head. But when you ask somebody, hey, how can we go from this inches to miles, you are more likely to have somebody say, hey, I can change my inches to feet, and then what I can do is I can go from feet to miles. Now again, inches to feet, we just finished doing that. We need to know what's the relationship. 12 inches equals 1 foot. To do this step, we would need to know the feet to miles. Now this is where I have some people who come in knowing this, and others, this is where you get your introduction to it. 1 mile is 5,280 feet. So now what we need to do is we need to go through our conversion process just like we did before, but we're going to have to do it twice. So let's start. If we start with this first one, I want to know how many miles there is in this value of 47,100 inches. And what I need to know is we need to not go with miles, we need to go to feet first. And then we need to do our feet in inches here. Whew, almost caught myself there. I was going too far down the road. Now, if you're looking at this going, my answer's not even in there, it will be. And the truth is, we're using this as an example to set up a basic rule so that you don't have to go through what we're going to show you here. So we said 1 foot is 12 inches. So in order to solve this, we multiply both sides by the 47,100 inches. These cancel, and we get x feet equals 1 foot. Actually, I'm going to try and put this together the way I did on the last example. 47,100 inches times 1 foot over 12 inches. Now, I'm not actually going to calculate this for a reason. So I'm just going to leave this. So I'm going to box this in orange. So now this answer represents a value here, and now I need to go from feet to miles. Now, if I were to do that, that means I have to set up another ratio for this step. Now, what I really want is to know how many miles there are in what I started with, but the thing that goes here has to be feet. Now, I'm going to go ahead and cross these out here, because if we come back here, the inches have already canceled. I'm actually going to leave them in there. But what I need to do is, I'm not going to, if I would have actually calculated this number, that number would belong right here. But what I'm going to do is I'm going to leave it as this expression. 47,100 inches times 1 foot over 12 inches. And the truth is, I don't even need to put that foot there because it's in my work right here. Now what I need is my relationship between miles and feet, and this is my conversion factor. 1 mile is 5,280 feet. Now, in order to solve for this x, I am going to multiply this is where things are going to get really tedious. I am going to multiply by this over 1. Now, if you're going, oh my God, this is going to look like a mess. It will. And I got to check to make sure that I'm not going off the screen here. Whew, this is going to be a tight fit. But this means I'm going to have 47,100 inches times 1 mile over 5,280 feet. Okay, I got to make sure I'm still on there. Okay, I am. You might have to zoom in to make sense of this. Here's the big moment. This whole thing here cancels that whole thing down there in the denominator, and we are left with x miles equals. Now over here, this looks like a mess, but here's what I'm going to do. All I'm doing is multiplying a bunch of stuff together here, so I'm going to move the 47,100 inches out front. And then the next thing that I am going to put in there is going to be, let's see. Oh, somebody's got to correct me on this. This is my 1 foot, and this is my 12 inches. Damn. You guys are going to have to watch me when I'm in class. When I screw something up like that, you gotta correct me on that. So going back here, I was jumping ahead to my feet mile thing, which is easy to kind of get confused sometimes. When we multiply by this, we get 1 foot, 12 inches here, and then we have this thing here, which is 1 mile, 5,280 feet. So if you look at this structure that we have put together, this inch cancels that inch. This foot cancels that foot, and we are left with, on the right, the unit of a mile, which is what we want. Mathematically, what this tells us to do is we start with the number 47,100, and when we look at, and when I process these strings of calculation, the way I do it is by taking each individual conversion factor, because if you look at this, here's our first conversion factor that we used in going from inches to feet, and then here is our conversion factor that we used to go between feet and miles. But our units are arranged so that they are diagonal, so they cancel. And when someone says, well, do I multiply or divide by 12 or the 5,280? You don't have to know that off the top of your head. You just need to be able to structure this calculation so that the units will cancel, and then look at this like a pure math problem. Because when you have 47,100 and you multiply by 1 over 12, that is the same thing as dividing by 12. And then when you go to the next conversion factor and you see I am multiplying by 1 over 5,280, that is the same thing as dividing by 5,280. So in order to calculate this, all I would do is start with 47,100, and then I would divide by 12, and then I would divide by 5,280, and that would give me a value of 0.7434, and I'm rounding to the fourth decimal place here. Okay? Now, if I gave you a more complex one where you had to go through a third unit, this would get really, really messy. But the big lesson, and I'm going to build off this by doing a follow-up example at the beginning of the next video to review this. The biggest rule that you need to remember is when you want to do a conversion and go from one unit to another unit, and you need to get the value, you have to know some conversion factors. We talked about those earlier. Some of them you have to memorize. If they're metric in nature with the prefixes, you need to be able to create them on your own. But once you have the conversion factors down, what you're going to do is you are going to set up a mathematical expression where you start with the value you're given with, and then you work through various conversion factors, but you arrange the conversion factor so that units are diagonal from each other so that they cancel. Because as they cancel, they go away, but the numbers are left behind, and the numbers tell you what math to do. Now, I also want to finish with one conceptual thing here, and this is the beautiful part about the math that this is based on. Technically, when we look at this, this is a value of 1 over 12. But from a conceptual perspective, that is equal to the value of 1, because 1 foot and 12 inches are exactly the same length. So even though the math here tells you divide by 12, you are not altering any of the value of this length that you're dealing with. You are just converting it into a new unit. And the same thing applies to this second conversion factor. That is conceptually equal to the value of 1. And if you remember in your basic math that you learn in Algebra 1, you can multiply a value, they call it the multiplicative identity property of 1. You can multiply a number by 1 and it ends up being itself. And you can do that as many times as you need to. But what we are doing is every single conversion factor that we are going to make use of, even though we say things like 1 foot is 12 inches or 1 meter is 3.28 feet, when we express those as a fraction like this in the process of doing a unit conversion, you are simply going to be told to multiply or divide by something, but that overall value is just the conceptual value of 1. So the value might be changing, but the concept of what it represents in the real world is not changing. Okay? So this is, I want to say this is probably the most important rule where we need to start our unit conversion process. I am going to give you problems where I will say, here is this unit or this measurement in this unit, and I need you to convert this to this other unit. And what you're going to have to do is something like this, because I'm not going to give you conversions that are going to be super simple. I am going to make you have to go through multiple steps. And you don't have to do this ratio thing, because in the end, what we've learned from this example is we can just start with the first value, and if we know the conversion factors that we need, we can just set them up so that units are diagonal from each other, and that tells us where to place values, and that in the end tells us what math we need to do to get our right answer. So this was a big one. And again, I'm at 30 minutes again. Oh well. So the follow-up for this, we're going to start with another example of this, but we're just going to jump to the final idea here and show you how this works in a couple examples. and then I got some practice for you to do. So, I love this stuff. Okay, see you next time.